let me define a notion of a rather natural normal subgroup of a group. Here's the definition. So if you have any group G, the group that's denoted Z of G, which is called the center of G, consists of the elements Z in G that commute with everything. They commute with everything in G. So the center can go all the way from G to the identity. This is a subgroup. In fact, a normal subgroup. As you can check by multiplication and by conjugation. I won't do that for you. These kind of things you should start checking yourself. It's a normal subgroup of the group. We're going to exhibit it pretty soon as the kernel of a homomorphism, which will validate your hope that every normal subgroup is a kernel. All right? The center can go all the way from E to G. For example, if G is abelian, what's the center? If G is abelian, the center is everything. The abelian means the group elements always commute. So G is equal to ZG if and only if G is abelian. If G is equal to the symmetric group on n letters, we're going to see that Z of G is the identity element. There is no element that commutes with all permutations except for the identity. That's not obvious. It's a good exercise to show that no matter what permutation you write down, you can find something that doesn't commute with it. We'll learn how to do that when we get into permutations, have a better notation, etc. If G is the general linear group, and I think Peter ended with this, the center of G consists of the diagonal matrices. That's a famous lambda is in R star. That's a famous result in linear algebra, that if you have a non-diagonal matrix, and by diagonal I mean the same entry on the diagonal. If you have a non-diagonal matrix, you can find something that doesn't commute with it. So this is a very useful notion. To any group is assigned a canonical normal subgroup, quite frequently trivial, which is its center. The center is an abelian group, because if it commutes with everything in G, it commutes with itself. So it's a normal subgroup, which is abelian. There are plenty of groups, like the symmetric group, which have no abelian normal subgroups. So there are going to be many cases where we get a trivial center.